Hey everybody, this is part 2 of the cutting torch how-to video. I've got a little torch cutting setup here that I set up real quick. It's raining outside, so I can't cut outside and let the sparks go on the ground. So I have this open steel drum that's cleaned out, and I'll be able to direct all the sparks into here so I don't endanger anything, setting anything on fire in my garage. Just have a bar set across here. I'm going to do a couple test cuts on this. I can lay it on here, cut it with the torch, all the sparks will go in here, and it'll be a pretty safe way to cut. So let's get started, and I'll show you how to set up the regulators and set the correct pressures on your torch. Alright, we're back at my oxygen tank and regulator. See, both gauges are at 0 and the tank is closed, so I'll start by opening the tank slowly. And then, like I mentioned before, you open the oxygen tank all the way until it stops, and that'll prevent oxygen leaking out from the packing of the valve. So we're at about 800 psi in this tank, which is plenty. Now you want to set the outlet pressure. Now for cutting, you want a lot of oxygen pressure, because the jet of oxygen going through that center hole in the torch nozzle is what does the cutting. So again, when you get some books on cutting with oxyacetylene torch, it'll cover some basic pressures for what you should start off at. But from my experience with this particular torch tip, this is my smaller torch tip, I want to set this to about let's do 20 psi. So we'll start by opening the oxygen valve. Oh, I didn't close that. That was a mistake on my part, but you start by opening the oxygen valve. And then I just depress this lever here to allow full oxygen flow. And I will set the pressure by turning in the regulator. About 20 psi. Now the reason I allow the gas to flow when I'm setting the pressure is it's not too noticeable on this one. You might have noticed the needle move a little bit, but when the flow of gas stops, the pressure on the regulator will raise up a little bit. So you want to set this pressure to what the pressure will be when it's flowing. Now let's go on to the acetylene regulator. Okay, here's my acetylene regulator. Sorry, it's kind of in the shadows here because the tank is shorter. But I will start by opening the acetylene valve, again slowly, and you want to be careful, or take note to not open the valve too much. Just a half a turn is plenty. And you see I barely have any acetylene left in there, but I have enough for this video. Only open the acetylene valve a half a turn, because in an emergency you can quickly and easily do a half a turn on the acetylene tank valve and you'll shut off all the fuel to your torch. So if there's no fuel, there's obviously not going to be any fire. And once again, I will open the fuel valve on my torch a couple turns, and then turn in the acetylene regulator to, again, my experience, let's do about 6 psi, and I'll close. Now see how that pressure jumped up a little bit? It's not flowing now, and now it is. That's why it's important to open your torch valve when you're setting pressures. So this is set to about 6 psi, and that should be sufficient for this torch, or for this tip rather. Okay, so I have my torch set up here, and I'm going to talk just a little bit about the flame before I light it, because it'll be easier for me to not have to talk over the flame because it's somewhat loud. So I'll first crack the acetylene valve, maybe 1/8 of a turn, not very much, just a little bit, just enough for a little gas to flow out, and then I will strike my sparker, and I'll ignite the flame, and I will increase just the acetylene, no oxygen at all at this point, just the acetylene, until the flame becomes kind of feathery and loud, and the amount of soot that the flame produces is lessened. It's still going to be pretty sooty, but it won't be as sooty. You'll see when you light it. And then at that point, once the acetylene flame gets feathery, you want to increase the oxygen slowly until you see two distinct cones of flame. There'll be a short inner cone, about a 1/4 inch long, and then a longer outer cone. And that outer cone will get shorter and shorter as you increase the oxygen. You want to increase the oxygen until those two cones come together. And at that point, press down the oxygen lever, this one here. You're pressing that lever just momentarily, and most likely the outer cone of the flame will jump out of the inner cone, and then it'll go back in when you let off the oxygen. So you want to crack open the oxygen valve just a little bit more, so that when you press on the oxygen lever, the shape or size of the inner cone does not change. So I'm going to hook up a shade 5 lens here onto the camera, and I'll see if I'll be able to demonstrate this to you. Okay, so I hope that cleared it up a little bit. The image wasn't as clear as I would like, but it's better than nothing. You'll definitely see what I'm talking about when you light your own torch. Now, I'm about to do some cuts here, but I want to talk just a little bit about how you actually make the cut. So, firstly, as with anything, with welding or anything, or soldering, whatever, you want to have a nice, you don't want to just be holding it with one hand and you're all floppy. You want to brace yourself somehow, something like this. I'm going to make some cuts across here, so I'm going to brace my hand like this, and then I can just, with my wrist, I can move across and make some cuts. Or if I was making a longer cut, I can roll my hand, start like this, make a cut, and then roll like that. Do a couple dry runs, just like with welding, if you're making a long cut with a weld, or with a welder. So, to cut, you'll start on the edge, and you'll heat up the edge to heat up a little spot in the edge till about red hot, orange hot, something like that. And then when it's ready, then you push down the oxygen lever all the way, and you'll see it'll make a cut, and then you slowly move across, and the jet of oxygen will cut through the steel and make a cut. Now, after a couple practice runs, you'll discover what is too fast and what is too slow. If you just cut across too fast, the oxygen and steel won't be burning fast enough, and the cut will just go out. You'll have to relight your cut, and it'll be a little unsightly because there'll be a little hole in the cut where you start again. And on the opposite side of things, if you go too slowly, you'll technically still cut the piece, but all the slag will collect behind the cut and it'll re-weld the two pieces together, and it's just slag holding it together. So you can hit it with a hammer or bend it with pliers and break the cut piece off, but the cut will definitely be ugly. There will be a lot of slag on the back side, and if you're cutting a really thick piece, it's really tough because you can't bend it or break it off that easily, but you can't go back and cut again because the slag doesn't cut, because the slag is already oxidized, it's already burnt. And that's how the steel cuts, it burns, it doesn't just melt and blow away. So if you do have slag, you can heat it up and blast it away with oxygen, but it really doesn't work too well, and it's a waste of oxygen. So you have to practice and get the hang of moving at just the right speed. So I'm going to make a couple cuts, and I'll also give you a demonstration of what not to do, of cutting too fast and too slow, and show you what it looks like and what it does. Alright, I just made a couple practice cuts to make sure my settings were right, and to make sure my technique was good, and it is. So, let's fire up the torch, and I'll do a couple good cuts, and then I'll do two bad cuts, slow, well, something too fast and too slow, and you'll see what they look like. Those are three decent cuts. I accidentally welded a little bit of slag to it, but it came off pretty easily. So now I'm going to cut too slowly. See, it didn't come off. It re-welded with slag. Now I'll cut too fast. Now let's take a close-up look at those two mistakes. See, on the cut closest to the end, I made the cut went all the way across, but I traveled too slowly, and it re-welded. Look at all that slag. See, you can see it just hanging down. You can see on the top, it did cut through about halfway, but on the bottom half, it re-welded. And if I hit that or pulled it with pliers, it would come apart, but it would be a very ugly cut. And on the second cut, you see it only cut part way because I got the cut started, but I went too fast, and it just simply went out. Okay, I've got my piece of scrap plate metal here, and I have the symbol drawn out. And there's all straight lines that I need to cut. And in this particular situation, I'm not just cutting something apart to scrap it. I'm cutting it apart because I want it to look a certain way, so I want to be accurate with it. This is a pretty simple trick. You get yourself a piece of angle iron, or even a block of steel, or anything straight and non-flammable will do. And a C-clamp or vice grip or something like that. Place it along your straight line. And keep in mind that you're not using an X-Acto, so you don't set it up with the edge of the angle iron right on the edge of the line you want to cut, because this torch tip, let's say that's I don't know, 3/8 of an inch in diameter, 5/16 maybe, and it cuts from the center of that tip. And in addition to that, depending on the size of the height of this angle iron, a different part of your torch tip will ride against it. So for example, on this tip, this fat part right here is riding against the angle iron. So I want to have it back about like this to make a cut right along that line. So that's how I'm going to set up all the cuts for this piece. So on the next cut, I didn't want to cut too far and cut into the vertical pieces of the Chevy bow tie. So I clamped this black piece of steel here, so when I run my torch along the angle iron, it will hit the black piece of metal. All right, there we go. It's all cut out. Now, if you watched all of those clips, you'd see that a couple times I messed up. I went a little too fast, a little too slow. This one part fell out on its own. It's normal for at least a little bit of slag to hold something together. There we go. Not too bad. Take a look at the back side. There's a nice cut right there. That one. That one too. It's pretty nice. On focus. I wish I knew how to focus, but anyway. So there you have it. So let's clean it up a little bit. Just put a nice finish on it with a flat disc on my angle grinder. Now I'm going to weld a little hanger to it so we can hang it up somewhere. Alright, so I have a big lock washer laid up there, and I have it propped up just with a little piece of metal, so that'll make a nice hanger. Well, there you have it. It's one completed torch cutting project. And as with a lot of other things, machining and welding and such, the setup took more time than the actual cutting and grinding. Just setting up that angle iron so you make nice straight cuts. So, when you're doing projects like this, remember to take your time when you're doing a setup, because when you take your time setting up, you'll definitely make your life easier when you go to actually do, weld your bead or make your cut or whatever it is. So I hope you guys enjoyed this video. I hope this clears up some of the questions that you have, or that you had, regarding using an oxyacetylene cutting torch. If you have any questions, comments, leave a comment down below. I'd love to hear from you. I'd love to hear your thoughts or suggestions or whatever you might have. If you enjoyed this video, make sure to leave a thumbs up and check out my other shop videos. I'm sure there's something else there that will come in handy for you. And so, once again, thank you for watching, and come back for more.